All right, looking good. So let me go ahead and start our recording. Does it really, Nichelle? All right, so this is a reminder, class connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate fully, but please do not share contact info during class for your own security reasons. Yeah, that's interesting how different they look on the different computers, right? All right, so there are actually, sorry, this should say 3. There are only 3 days left of the quarter. I forgot to change that, which means that we are ending very, very soon. Remember, we are ending on Monday. So today we are doing a final exam review. So you have some attendance due today, and sorry, you don't have notes due today. There are no notes for today. Instead, you have an extra credit game that you're going to play today. All right, so sorry, this should say attendance. This slide is all sorts of messed up. Come on, Miss Larkin, get it together. Don't forget we do have support today at 1 o'clock, so if you need help, especially with yesterday's lab, definitely come to support and we can work on the lab together. Keep in mind that the lab report is a big part of your grade, as is every lab and exam, and that it's one of the easier labs, right? Go ahead, tell me in the chat box, how are you feeling about yesterday's lab? Those of you that have already completed it. Remember, I am zeroing it out today. So if you don't get it turned in by 4 o'clock today, you will have a 0 until it gets turned in. Yeah, it was definitely pretty easy. Awesome. All right, so make sure you get the motor lab done. It's one of the easier ones. David, if it's not working, make sure you email me so we can troubleshoot that, because we are almost done with the course and we got to make sure we get that done. Perfect. Oh, wait, thank you. All right, everyone. So courses are ending on Monday, October 28th at 11:59 p.m. I will not accept assignments after this, even if you have tech issues on the last day. So tech issues are not an excuse. If you find that K-12 website is not working during the last hour or something of the day, that is not an excuse, and I will not accept assignments after this time. So remember, this is my only hard deadline that I have in my entire course. So make sure you get things done and make sure you get them done early. Remember, the course, the K-12 website does tend to crash, but again, that is not an excuse for not getting everything done, because you've had plenty of time to get caught up. All right, thumbs up, everyone, if that makes sense, if you feel good about that, if you're understanding all of that. I know most of you that are in class here are doing very well. That's one of the advantages of coming to class. You get a lot of things done, right? Perfect. All right, so taking a look here, remember that lab reports and exams are worth 60% of your grade. If you are someone that's just been phoning it in for lab reports and exams, meaning that you have not actually been doing them, or you've been submitting things that are blank, or you've been submitting things that are barely completed, you will not pass my class. All right, so remember, if you do not have lab reports and exams done, what is the highest grade you could possibly get in my class? If you do not have any of your lab reports or exams done, or you haven't done them correctly, or you've left them blank, what's the highest grade you could possibly get in my class? What is the highest grade you could possibly get in my class? Take a look at all these other sections. Yeah, you could only get a 40%. Only get a 40%, right? So 10% from attendance, 10% from Star 360, and 10% from notes, which if you're not getting any of your lab reports and exams done, that probably means you're actually not attending class either, which means then your highest grade you can probably get is only a 30%. Exactly, Johnny's, right? So keep that in mind, that you need to be doing your lab reports and exams. If you're not doing them, you're not going to pass my class. All right, so you got to make sure you do them correctly. You got to make sure you do them well, and you at least need to be passing them. You at least need to get D's on them, not Z's. Yeah, Jelly, so everything's been zeroed out for the most part, except for the most recent lab, right? Because that one I'm zeroing out today, okay? And then your final exam will be due tomorrow, and so at 4 o'clock tomorrow, your final exam will be zeroed out. I'm not going to zero it out before you've actually had a chance to do it, though. Thumbs up, everyone, if that makes sense. So everything by tomorrow should be completely zeroed out. If you're passing by the time things get zeroed out tomorrow, you will pass the course. Perfect. All right. So let's go ahead and take a look at today's objective. Again, today is a review, so we're taking a look at everything that we've looked at throughout the quarter. So we're going to take a look at how matter and energy interact, the laws of motion, forces, different types of forces, energy, work, and power. We're going to talk about waves and review electricity and magnetism. So we're going to take a look at a bunch of different topics. We're going to jump all over the place, but this is good because this is everything that you have learned over the past 9 weeks. Sorry, guys, just taking care of my daughter really quick. Cool. All right, so here's how we are going to do today's review. So today you do get extra credit for participating. So what you're going to do is you are going to go to kahoot.it. That is the website. It looks really funny, but the website is actually kahoot.it. You can also go on your phone or a computer browser. There's also an app. So if your phone is really fast, you can actually download the Kahoot app right now because this does work better on the Kahoot app. But either way, you can go to kahoot.it on your phone. You can go to kahoot.it on a computer browser. So if you have Google Chrome open right now, you can go to kahoot.it. Thumbs up, everyone, if that makes sense. All right. Some of you may have played this in the past. Looking good. Then what I'm going to do is in a moment, I'm going to start the game and I will give you the game pin. So just wait a moment. I'll give it to you in a few moments. And then you will need to match the pattern on the screen. All right. So it is going to give you a pattern. You will need to match it to make sure that you are actually a real player that's playing. Otherwise, we end up with a lot of bots and that's an issue. Okay, then please enter your first name and the initial of your last name. Again, first name with your last initial. All right, if you do not enter this correctly, then I won't know who to give extra credit to. Okay, now here's the deal. Just do your best. I will not grade your extra credit based on whether or not you get everything correct. I'll just grade it based on whether or not you participated in every question. All right, go ahead. Let me know in the chat box. Give me let's see here. Give me a rainbow if that makes sense. So just do your best, all right? Right or wrong doesn't matter as long as you are participating. I just need to see that you answer every question. Now, if for some reason the Kahoot game is not working, you can play in a private chat. Just let me know and I can open one for you. Or you can double click on my name. So double click on my name in the participants area and send me a message. And that will also open a private chat. Okay, so either of those are fine. You can play kahoot.it on your phone, kahoot.it on your computer browser. You can play on the Kahoot app, or you can play in the private chat. Either way, though, you need to answer every question to get your full extra credit. Okay, so let me go ahead. I am going to get this game started, and let's go ahead and get that up. All right, so we are playing Classic. All right, so we want the randomized order of answers, two-step join. Looking good. All right, so I'm going to go ahead and tell you what this pin is. So the pin is 573791, and then you will need to match the pattern that's underneath here, and the pattern changes every 7 seconds. So I'm going to read it out for you about 10 times as it changes. Blue, yellow, red, green. Blue, yellow, red, green. No worries, David. Just go ahead and get into the kahoot.it. So again, the website is kahoot.it, or you can use the Kahoot app. Your pin is 573791, and the pattern, I will show you that in a moment. Green, red, blue, yellow. Green, red, blue, yellow. All right, again, I don't know who this is. You need to enter your first name and the initial of your last name. First name and initial of your last name. Thank you, thank you. All right, yellow, green, blue, red. Again, you have to match the pattern quickly. You have to match the pattern quickly. Green, yellow, blue, red. Blue, red, green, yellow. I'll give you about 5 more readings. It's so that bots cannot enter. Sorry, blue, yellow, red, green. Blue, red, green, yellow. Red, yellow, green, blue. All right, I need everyone in here. You cannot get extra credit if you are not playing. Yes, it was, David. Blue, red, yellow, green. So we were having an issue where random people were joining because you can join at any time as long as you know the pin. Yellow, red, green, blue, which meant random people were entering our game and just guessing, and it was very annoying. Yellow, green, red, blue. Yellow, green, red, blue. All right, blue, yellow, green, red. Yeah, exactly. Looking good. All right, gonna read it off 3 more times. If you're not up on the board, you're not getting extra credit. So again, this is an easy way to get extra credit. Yellow, red, blue, green. There's 1. Yellow, red, green, blue. There's 2. And 1 last time. It's fine, Antonia. Green, red, yellow, blue. And then we're gonna go ahead and get started. Get your name up here. All right, I'm going to go ahead and take a picture of who I've got up here really quick. Perfect. All right, everyone, let's go ahead and get started. All right. So let's take a look at this. Which of the following is a correct characteristic of an independent variable? Red, it is the result or effect. Blue, it is what is changed on purpose at the start. Yellow, it is graphed on the vertical y-axis. Or green, it is what is measured at the end. Independent variable. Red, result, effect. Blue, changed on purpose at the start. Yellow, vertical y-axis. Green, measured at the end. Okay, Makai, I'm going to open up a private chat for you, and you can play in the private chat. So you should see that pop up at the bottom of your chat screen. All right, anyone else that needs to play in the private chat, let me know. You got to make sure you answer all of them. Good. So independent variable is what gets changed on purpose at the start of an experiment. Yes, Jelly, I will open up a private chat for you. There you go. Just make sure you're answering all of them in the private chat. Anyone else, make sure you let me know. All right, so let's go ahead and take a look at that. All right, I got Jaden, Landon, Janice, David, and Vanessa up on the leaderboard. Let's go ahead and take a look at the information for this. So remember, independent variable is the cause of an experiment. It's what we start with changing in an experiment. Dependent variable, just like the word dependent, depends on what happens in the experiment. So it's the effect or the end result that we are measuring. When we graph these, independent variable gets graphed on the horizontal x-axis. Dependent variable gets plotted on the vertical y-axis. All right, and these graphs allow us to see relationships between the two variables. Go ahead, give me a thumbs up, everyone, if that makes sense. Thumbs up if that makes sense. Perfect, looking good. All right, anyone else that needs to play in the private chat, let me know. Looking good. All right, so let's go ahead. A lever rotates around a point called the what? All right, red screw, blue fulcrum, yellow wheel and axle, green wedge. Go ahead, let me know. All right, perfect, Hannah, you can play in the private chat. Private chat people, I need your answers. So Jelly, Micaiah, make sure I get your answers too. You can say red, blue, yellow, green, red screw, blue fulcrum, yellow wheel and axle, green wedge. 5 seconds. Perfect. All right. If you just joined us, we are currently playing a Kahoot game. Go to kahoot.it on your PC or phone. You can also download the app. And then the pin is 573791, and then you need to match the pattern in the lower right-hand corner, which changes every 7 seconds. Yes, all right. So a lever rotates around a point called the fulcrum. Looks like we got some of us that got that correct. Landon, Jaden, Taja, Janice, and David on the board. Kimberly is the highest climber. Let's take a look at the reason behind this. All right, so a lever is a bar sticker board that rotates around a point called the fulcrum. You can see the fulcrum here. It can be in the center, the end, right? But changing the fulcrum's position does change the type of effort force that you need in order to do work. So take a look right here, everyone. What would the fulcrum be? A, B, C, or D? Tell me in the chat box. Where is the point around which this lever right here is rotating? Which is the point where this lever is rotating? Yeah, B right here. So B right here is the fulcrum. That is where this would rotate. Perfect. Looking good. All right, next question. How much of a 0.89 gram per milliliter dense object would sink beneath the surface of water? Red, 89%, blue, 13%, yellow, 100%, or green, 0%. Okay, we've got an object that is 0.89 grams per milliliter. How much of it sinks below the surface of water? 89%, 13%, 100%, or 0%? Awesome, I got an answer from Hannah in the private chat. I see Micaiah typing perfect. 2 seconds. Yes, 89%. Remember, all we need to do is change this number into a percentage when an object is in water, and that tells you how much of it sinks. So 89% of it would be under the surface of water. The other percentage of it, which is about 11%, would be above the surface of water, kind of like an iceberg. Remember, icebergs, part of it is above water, but most of it is below the surface of water. All right. Jaden, Taja, Landon, David, and Vanessa on the board. Jorge, the highest climber right now. Let's go ahead and take a look at this. So buoyancy is an upward force that makes things float, right? If you know the density of the fluid, you can estimate the density of the object floating. So since water's density is just 1, then for every object in water, the amount that is underwater is just the same as its density turned into a percentage. Thumbs up, everyone, if that makes sense. So all you need to do is take this number right here and turn it into a percentage. So 0.97 becomes 97. 0.75 would become 75. Perfect. All right, looking good. Is there anyone else that needs to be in a private chat? Remember, if you are not playing on the board or you are not in the private chat, you will not get extra credit. The only way you can get extra credit is either by joining in the game, which the information will be at the bottom, or by playing in a private chat. All right, what is velocity? What is velocity? All right, red, the speed of an object. Blue, the change in speed of an object. Yellow, the speed and direction of an object. Or green, the distance an object moves. What is velocity? 20 seconds. Again, if you just joined us, Kahoot.it. The pin is 573791. And this pattern you have to match. It changes every 7 seconds. Awesome. Thank you, Jelly. I see your answer. Thank you, Micaiah, Hannah. All right, yes, velocity is actually both speed and direction. Remember, speed of an object, the direction does not matter. Think about how your speedometer, whether you're going forwards or in reverse, your speed is always the same. Thumbs up if that makes sense. You can go 30 miles per hour forward, 30 miles per hour backwards, and it will still always say just 30 miles per hour. Yes, however, velocity, on the other hand, it does matter. Taja on fire. Jaden, David, Lorelai, Landon on the board. Let's take a look at this. All right, so again, speed is just how fast an object moves. Again, we measure it in distance per time, like meters per second or miles per hour. Velocity, though, is both speed and direction, which means that you have to state, is it going to the right? Is it going to the left? Is it going up? Is it going down? And there are actual negative directions, right? You could say -3 meters per second to represent that it's moving to the left in the negative direction. So velocity, the direction does matter. Next question, if the acceleration of an object in motion is negative, what is happening? Velocity is decreasing, red. Blue, velocity is at rest. Yellow, velocity staying the same. Or green, velocity is increasing. Negative acceleration, what is happening to velocity? Awesome, thank you, Hannah. Thank you, Micaiah. 10 seconds, 5 seconds. Answer quickly. Just guess. Remember, as long as you're answering, you're getting extra credit. Right or wrong doesn't matter as long as you are answering and participating. Thank you, Jelly. Yes, so in this case, velocity is actually decreasing. Remember, negative acceleration means your velocity must get smaller. It must go down. All right, so let's go ahead and take a look at that. Taja, David, Jaden, Landon, Kimberly on the board. Taja still on fire. Let's take a look at acceleration. All right, so acceleration is the change in velocity. So if you have positive acceleration, that means your change is getting bigger. It's increasing, right? So if you speed up from rest, if you speed up while you're moving, that is positive acceleration. Negative acceleration is the opposite, right? You can still have acceleration, but if it's negative, it means that your velocity is decreasing. It's changing in the negative direction. It's getting smaller, right? So you're slowing down or you're coming to a stop. Go ahead, give me a star if that makes sense. Give me a star if that makes sense. Perfect. Thank you, Vanessa, Janice. Awesome. Kimberly. Yes, love it. Thank you, Micaiah. All right, next question. What is it called when light bends as it enters a different substance? Is that called red, reflection, blue, transmission, yellow, refraction, or green, absorption? 20 seconds. Light bending, bending light. Is that reflection, transmission, refraction, or absorption? 15 seconds. If you're not sure, just do your best guess again. As long as we're answering, we're getting extra credit. Private chat people, make sure I'm getting yours. I got Micaiah, Jellies, Hannah, make sure I get yours. Thank you. Yes, this is actually called refraction, refraction. Let's go ahead and talk about that. Taja, David, Jaden, Landon, and Nichelle now on the board. Let's take a look here. All right, so refraction means that light bends as it enters a substance and it slows it down, right? So if you take a look here, light travels slower in water than in air. So as it goes into the water, it slows down and it begins to bend. This is why things look so weird underwater, right? This is why fish are never in the spot that you actually think they are, and why when you stick a pencil or a chopstick in water, it looks like it is bent. Go ahead, give me a smiley face if you've ever seen that, if that makes sense. So when things go into water, they look like they're slightly out of place. They look weird. Yes. Perfect. It's because light is bending. Next question. Which of the following is the force between two moving charged particles? Moving charged particles. Red, electromagnetic. Blue, intermolecular. Yellow, strong nuclear. Or green, gravitational. We've got two moving charges. What is that? Electromagnetic, intermolecular, strong nuclear, or gravitational? 10 seconds. Awesome, Micaiah, got yours. 5 seconds, Hannah and Jelly, make sure I get yours. Thank you, Jelly. Thank you, Hannah. All right, this one is actually electromagnetic, right? Anytime we talk about moving charges, we're talking about electricity. So that falls under electromagnetic forces. Let's take a look at the different types we got. Oh, David taking the lead. David, Jaden, Taja, Landon, Kimberly on the board. Let's take a look here. These are what are called non-contact forces. All right, so remember, gravity acts based on mass between all objects. The more mass, the more gravity you have. Electromagnetic forces are between two moving charged particles. This is both for electricity and magnetism. Intermolecular forces mean that different molecules are slightly attracted to each other. And strong nuclear force is the force that is holding the nucleus together. Thumbs up, everyone, if this makes sense. Oh, no, Tasha. Tasha's like, why can't I click on it? I'm sorry. It's such a silly way to lose your streak, right? It's okay. You're still getting extra credit, so it's all good. All right, everyone, let's keep on moving. What type of energy is stored in compounds and released in reactions? Red, chemical, blue, sound, yellow, electrical, or green, light? What type of energy gets stored in compounds and then released in reactions? Chemical, sound, electrical, light. 15 seconds. Thank you, thank you. Oh, looks like we all answered this really fast. Yes, this is actually chemical. So chemical, remember, compounds are chemical compounds, reactions are chemical reactions. So let's take a look at that. David, Jaden, Taja, Landon, Kimberly still on the board here. Let's take a look at chemical energy. So again, this is the type of energy stored in compounds released in reactions. So for example, batteries have chemicals in them that can then get released to create electricity for a flashlight. Gasoline can get burned to make a car move. You can't believe you remembered it. And for example, butane lighter takes the compounds butane and oxygen, uses a spark to make them react together, creating carbon dioxide, water, and heat in the form of a flame. Go ahead, give me a lightning bolt if you understand here. Lightning bolt if you understand this. I know, it's been 10 weeks, everyone. It's been a long time. I'm impressed that you are doing so well too. But this just goes to show you that you actually already know a lot about physics. Perfect. All right. What is the energy of motion called? What is the energy of motion called? Red, thermal, blue, nuclear, yellow, potential, or green, kinetic? What is the energy of motion called? Awesome. Private chat people, make sure I get yours. No worries, Jorge. Glad you were able to get back in. Make sure you rejoin the game. The info is at the bottom, and remember to match up the pattern. It changes every 7 seconds. I wish it changed at a slower rate, or I could choose the rate that it changed. All right, looking good. So let's see here. Energy of motion is kinetic. Yes, remember the word kinetic literally is our word that we've talked about, meaning motion. I'm so sorry, David. That's why we are reviewing. I got Jaden, David, Landon, Tasha, Kimberly on the board. Jaden has taken the lead. Go, Jaden. Let's go ahead and take a look at our information here. So talking about mechanical energy, right? This is our category. There are two types. Kinetic energy is the energy of motion. Potential energy is the energy that is stored because of how high it is, right? So you can see the higher up, the more potential energy you have. But if you're not in motion, you have no kinetic energy. Once you begin falling, you have both. And when you get to the bottom, you're going as fast as you can, so it's all kinetic, but you're at the lowest point, so there's no potential. Go ahead and give me a music note if you understand. Music note if you understand. Thank you, Landon, Kimberly, Nichelle, Micaiah, Hannah, Janice. Awesome. Let's keep going. Next question. In cold objects, molecules are moving. Red, quickly. Blue, slowly. Yellow, not moving. Or green, they are not present. You can tell that I was having a hard time coming up with some answers. 15 seconds. Cold objects, molecules are what? Thank you, Micaiah. I see your answer. Thank you, Hannah. David. Right. I was like, what's another one I can choose? Thank you, Jelly. Yes. All right. Cold objects, they are moving, but in this case, they're actually moving slowly. Remember, just like you, when you're cold, you kind of want to conserve energy. So you slow down, you try to bundle up, you stay in place. When you're hot, though, you can move faster, right? Think about when you're running around, you're faster, right? You're hotter. Thumbs up, everyone, if that makes sense. So quickly is hot objects, slowly is cold objects. There's no such thing as molecules not moving, though. That's impossible. They all move a little bit, at least. And obviously, they are present. Molecules have to be present. Good. All right. Jaden on the board. David, Landon, Tasha, and Kimberly on the board. Landon on an answer streak. Love it. Let's take a look at our info here. This is what is called the kinetic theory. Remember, kinetic meaning motion. So this is the theory that molecules in motion are what heat is. So David, if molecules did not move, that would be what is called absolute zero, which would be the coldest temperature in the universe, but we have never been able to reach that. So we've gotten really, really close to absolute zero, where cold objects almost stop moving, but we haven't quite reached it. Yeah, so hot objects, molecules have a lot of energy, so they can move really fast. They can even become liquids and then gases because they're moving so quickly. Cold objects, they move very slowly. They kind of just vibrate in place. And this is why we have things like solids. They're moving so slowly that you cannot see them moving, even though they are actually moving. If you were to zoom in on any solid object, you would see that the molecules are vibrating, moving slowly in place. Awesome. All right. Hi, Alicia. Go ahead, join our Kahoot if you haven't already. Looking good. All right, so next question. Which of the following ways that heat moves does not require matter? Red conduction, blue radiation, or yellow convection? Oh, the Kahoot music just got really creepy sounding. Sounds like Halloween music. Turn it down a little bit. All right, which one does not require matter? Red conduction, blue radiation, or yellow convection? 10 seconds, or sorry, 5 seconds. Thank you, Micaiah. Thank you, Hannah. Make sure I get yours, Jelly. All right, kind of split here. The actual answer is radiation. Yes, Jelly, it is radiation. So conduction and convection actually both require particles, both require matter. Let's go ahead and take a look at that. So we got Jaden in the lead, Landon on a streak, David, Kimberly, and Tasha also on the scoreboard. You knew it. So let's take a look here, everyone. So radiation is the special type of heat traveling. It does not need matter to travel. Instead, it carries that energy with what are called electromagnetic waves, which, remember, do not need particles. This is why sunlight can reach us through space without matter, right? There is no matter in outer space. So this is the one way that heat can move without needing that matter. Conduction and convection both require matter, right? Conduction requires objects to be touching and their particles to collide. Convection requires particles that can move around. So that means like fluids, like heated air rises up, cool air falls down, or liquids. Heated water rises up, cool water floats down, causing convection currents. Go ahead and give me a cloud or rainy cloud if this makes sense. Rainy cloud if this makes sense. Actually, I guess I should tell you to give me a sun. Go ahead, give me a cloud or a sun if that makes sense. Perfect. Thank you. All right, next question. What is the data at point A? Data at point A. So take a look here. Here's point A. Is it red 20 minutes, 43 degrees Celsius? 40 minutes, 25 degrees Celsius? 25 minutes, 40 degrees Celsius? Or 30 minutes, 38 degrees Celsius? Red, blue, yellow, green. What do you think? 10 seconds? If you're not sure, just guess. I know this is a harder one and you don't have a lot of time. Do your best. Think about what's the time at point A, what's the temperature at point A. Thank you, Micaiah. Thank you, Jelly. Yes, the answer is actually yellow. It was actually 25 minutes and 40 degrees C. Take a look here. So if you see, time is at the bottom. So point A is between 20 and 30 minutes at the bottom. So we know this is 25 minutes. And it is on this line right here, which is the 40 degrees C point. 40 degrees C point. Go ahead, give me a green check if you understand that. So if you take a look at the bottom, it's between 20 and 30, which is 25 minutes. If you look to the left, it's at 40 degrees. So 25 minutes, 40 degrees. Oh, no. No worries, Michelle. It's okay. I know it lags a little bit. It's a little annoying. I know. All right, Landon, Jaden, David, Kimberly, Tasha on the board. Landon with an answer streak of 8 correct answers. Very well done. It worked out. Oh, the red dot was 8. Yeah, sorry. All right, so again, when you read data, all right, you're going to take a look at the horizontal x-axis. You look at it up, down, right? So if you want to look at what the time is, you have to look down to the time axis. For the vertical axis, you read side to side, right? So if you want to look at the temperature, you need to go over to the side. I don't know, Tasha, you must have had a really big lead to start with. Now remember, the purpose of a graph is so that you can make predictions, right? So if you were to take a look at, for example, at 45 minutes, we don't actually have a data point right there, but we can actually predict what the temperature would be. Tell me in the chat box, what do you predict the temperature would be at 45 minutes? So looking down at 45 minutes up to the line, make a prediction by looking to the left. So you go from 45 minutes up to the trend line and then look to the left to make a prediction. Yeah, it would be 20 degrees C. Exactly. Very well done. Oh, I love the encouragement, David. David getting Landon a shout out. Perfect. All right, next question. Vectors describe red, both magnitude and direction. Blue, neither magnitude nor direction. Yellow, only direction. Or green, only magnitude. Remember, vectors are the arrows that we were drawing when we were talking about forces or velocity. Think about those arrows. Are they both magnitude, size, and direction? Neither magnitude nor direction, or only magnitude, which is the same thing as size. Amount. 3, 2, 1, give me an answer. Perfect. All right, this is actually both magnitude and direction. Oh, sorry, Jelly, make sure you're in the private chat so it saves your answers. But yes, the correct answer here is actually both. All right, let's take a look at this. We got Jaden, Landon, Kimberly, David, and Vanessa on the board. Vanessa with an answer streak. Awesome. Oh no, Landon, you lost your streak. All right, so vectors describe two things, both the magnitude, which is the amount, right? So the bigger the arrow, the bigger the magnitude or amount. The smaller the arrow, the smaller the magnitude or amount, as well as the direction. Keep in mind, arrows point in a direction, so it's actually showing both. Thumbs up, everyone, if that makes sense. It's actually showing both. For example, velocity can be demonstrated with a vector. The speed is the magnitude, how big the arrow is, and the direction of it is obviously the way that the arrow is pointing. Awesome. Next question. If you throw a heavy rock upwards in outer space, which way will you move? Red, down, blue, forwards, yellow, you won't move, or green, up? Which way will you move? Thank you, Micaiah. Hannah, Jelly, make sure I get yours in the private chat. Thank you, Jelly. 10 seconds. Thank you, Hannah. Oh, man. What's our answer? What are our answers going to look like? Yes, in this case, you actually move down. Remember, this is actually Newton's third law, which means that for every force, there's an equal and opposite force. So when something moves upwards, the other object is actually going to go the opposite direction and move downwards. Let's take a look at that. We got Jaden, Landon, David, Kimberly, Vanessa on the board. Jaden making a comeback. Sorry, Vanessa. Let's take a look at this. So, every force has an opposing force. For example, if you're in a rolling chair and you push forwards on your desk, you will actually move backwards. So you have a forward force, but there's also a backwards force. Same thing with a boat. If you jump off of a boat to the left, the boat will actually move the opposite direction to the right. I know, right? I was thinking about that the other day. I've been binge watching Doctor Who, and I imagine seeing all of those things in outer space, and I'm like, man, I'm so sad that I would never have qualified to be an astronaut because I'm too short. Plus, it would just be a lot. It'd be really hard work to become an astronaut, right? So for every action, there's an equal reaction that's opposite and parallel to it, right? So if you go forwards, the opposite parallel direction is backwards. If you go up, the opposite parallel direction is down. If you go left, the opposite parallel direction is to the right. Go ahead and give me a football, if that makes sense. Football, if that makes sense. I guess I should specify an American football. Thanks, Landon. All right, next one. What is it called when a circuit is complete and electrons can flow without interruption? So a complete circuit. Red parallel, blue open, yellow closed, or green series. So what is a complete circuit called where electrons are able to flow? It's able to work. 15 seconds. Answer quickly. If you're not sure, just guess so that you can get credit. Perfect. Thank you, Jelly. Thank you, Hannah. Thank you, Micaiah. There you go. This is actually a closed circuit, a closed circuit. So remember, when we're talking about whether or not a circuit can work, we only have two options. Either it's open, which means it's broken and doesn't work, or it's closed, which means that it is complete and it does work. All right, parallel and series are different things. Those have nothing to do with whether or not the circuit works. Thumbs up, everyone, if that makes sense. Thumbs up if that makes sense. I got Jaden, David, Landon, Kimberly, Vanessa on the board. Johnny's making a comeback. Yes. Let's take a look here. So closed circuits. Again, electrons can flow. Closed means it's complete. It's a complete circle, so electrons can go through, and light bulbs or lamps or whatever is using that circuit can work. Next question, what is the length of one complete wave cycle called? Is it red, the crest, blue, the wavelength, yellow, the amplitude, or green, the period? What is the length of one complete wave cycle called? Can we get 100% correct on this? Even if you did not know anything about this, you should still be able to get it correct, hopefully. 10 seconds. Use your context clues, everyone. Thank you, Micaiah. Thank you, Hannah. 4 seconds. 3, 2, 1. Thank you, Jelly. Oh, it's called the wavelength, right? It says the length of one complete wave. So length and wave should be the wavelength. Go ahead and give me a smiley face if that makes sense. And we'll go ahead and talk about what these other things are as well. Awesome. Thank you. We got David, Jaded, Landon, Kimberly, Vanessa on the board. Nichelle making a comeback with an answer streak. Let's take a look here. All right, so wavelength. Remember, waves repeat in a cycle. So the wavelength is the length of one complete cycle. That could be from crest to crest, which is the tops of the hills, trough to trough, which is the bottom. That could be two bumps, a bottom and a top bump, bottom and a top. Remember, amplitude is just the height, right? Frequency is the number of cycles in a second, and period is how many seconds one cycle takes, the time for one cycle. All right, next question. If work is done, is work done if you are pushing an object and it does not move? Red, no, blue, yes. 50-50. If work is work done if you are pushing an object and it does not move? Red, no, blue, yes. You got a 50-50 chance of getting it correct. Make sure you guess if you're not sure. Thank you, Micaiah. Thank you, Jelly. 10 seconds. Answer quickly. All right, the correct answer here is actually no. Let's take a look at why this is. We got David on fire, Jaden, Landon, Kimberly, Vanessa on the board. Take a look here. All right, so when we talk about work, what's important with work is we need three elements. We need a force, we need a displacement, we need it to cause a displacement, and that displacement needs to be parallel. So the issue here is, was there a force, yes or no? We were pushing an object. Was there a force, yes or no? Yes, there was a force. You were pushing it, yes. However, was there a displacement? Did it move? Did it move? No. So first off, it didn't even move, right? So there was no force. There was no displacement caused, as well as it just didn't move in general. So we can't even say if it was parallel or not because it didn't move at all, right? So when you are lifting an object up, that is work, right? Because, for example, you're lifting, your force is going up, and the object's going up. But if you were just holding an object and then walking around, that would not be work, because in that case, there would be no parallel. It would not be parallel, right? Displacement is in a different direction than force. Thumbs up, everyone, if that's making sense. So they have to be parallel to each other, and both of them need to exist. There needs to be both a force and a displacement. Perfect. Last question here. If a sound source is moving towards you, then frequency does not change. That's red. Blue, frequency is higher. Yellow, frequency is lower. Or green, pitch is lower. If a sound source is moving towards you, what's going to happen? I know. Yeah, in that big box picture, right, David? The other guy was just not being helpful. All right, 5 seconds. Oh no, Landon, what happened? All right, if it's moving towards you, frequency is actually higher. We got 100% correct on this. I love this. Hopefully you were thinking about an ambulance or a fire truck coming towards you. Its pitch and frequency both sound higher. Okay, if it was moving away from you, then its frequency and pitch would actually be lower, right? Let's go ahead and take a look. We got David, Landon, Jaden, Kimberly, Vanessa on the board, Taja back in with an answer streak. Let's make sure this makes sense. This is what's called the Doppler effect. Right? So again, if something's moving towards you, the sound waves get closer, and so you end up with a higher frequency and a higher pitch. If they're moving away from you, then you end up with it spreading out, so it is a lower frequency and a lower pitch. Go ahead and give me a, let's see here, what do we have? Do we have a sound one? Give me a clock if that makes sense. Give me a clock if that makes sense. We'll assume it's an alarm clock making noise. Perfect. All right, everyone. So let's take a look here. We got David in the lead, Landon in second, and Jaded in third. Go ahead, give them a round of applause from your smiley face menu in the participants panel. Go ahead, give them a round of applause. Love it. Thank you, David M. Thank you, Kimberly, Landon, Micaiah, Nichelle. Thanks for giving them a round of applause. All right, I'm going to go ahead and save these. And then I will also make sure that if you were in the private chat, so that was Micaiah, Jelly, and Hannah, you will get your credit as well. And I'm going to stop sharing this. Perfect. All right, everyone. So let's take a look here. I'm going to stop our recording.